Well, hi. Thank you for coming and joining me in my shop here this morning. It's March 1st, and just when I thought the rectifier tube situation with this radio couldn't get any weirder, yeah, it can get even weirder. So what am I talking about? So if you've been watching the videos, you know I've been hunting down the cause of low B+, and somehow it went away. The low B+ went away. I'm really not exactly sure why. Would appear that bad tube in the radio is substituted with another bad tube in the radio. Finally putting another tube in there, and I can't even remember what I did now, but somehow B+ went from 40 volts back to where it should be 129 volts. And here's the weird part. I walked in here this morning and I looked down, and here's the two of the three rectifier tubes. You see the green check mark on them? These are mine. These are from my... Wait a minute. If these are mine, the one that's in the radio is the original one. The original one's in the radio. B+ is normal. I don't know what's been going on. What has been going on? So we're going to turn the radio on. We're going to find out if it still produces the proper B+. Okay, I think we can just switch it right on. Let her rip. Now, I do have the dim bulb engaged. I'll get rid of it in a moment. Yeah, everything looks fine. Okay. So we're supplying the radio with 114 volts, and they are good volts too. None of this shabby bad voltage. Good. Fresh voltage, actually. The power station isn't that far from here. So, there we go. Well, I don't know. So, I don't know. This has happened to me a number of times in working on radios where I seem to have gone around in a big circle, and when I get all the way around, everything is just the way it was, but now it works. And I don't know. I don't know. So, okay, so we're going to be working on capacitors for the next while. Hopefully hopefully improving the performance of the radio as we go. Okay, got to pick a capacitor here. Okay, who's first? Let's see here. I like to do the audio capacitors first. And that's probably a couple down in this area. I see one of them's already been done. That's this one here. This is the one that takes the audio from the volume control and passes it to the triode amplifier, preamplifier, I guess you could call it. We have a big one here. Probably on the screen circuit, but I'm not sure. And we have this one, which is soldered to the chassis, which makes it an important one. This connection here goes, unless I'm mistaken, and I don't think I am. This one goes directly to one leg of the power cord coming in. I think that's the case. Let me just take a look at this just for a second, just see if that's really the case on the schematic. Okay, so we're looking for a capacitor that is connected to the chassis. Here it is here, C7. That's the guy for sure. 0.025. I could read on it. It says 0.025, so there's no doubt. This is the guy. The only connection between the main circuitry of the radio and the chassis. See, there is another connection over here, but I think as we traced this before, it really just connects to the antenna. It's actually electrically separate from the radio. So going back to this one, and does it connect directly to one of the power wires. So let's just follow this back. We'll follow this back. Okay, so if you go through the field coil, you can get there. So not quite direct. Okay, good enough. So what that kind of means, let's see, it's 120 volts across the string here. So here we have a direct connection to the power plug. And off of here we have a wire going up. Kinda. Yeah, I don't know what's going on. Okay, I don't know. Yeah, okay, never mind. Never mind everything that's in my head. So what am I doing here? So I'm looking for the capacitor. Does it connect? Yes, it seems to connect, but through the coil. Would you still get quite a lift off of this? Yes, you could. You could get quite a lift off it, I'm pretty sure. Plug this in so that this prong is the live one, and then you have liveness getting all the way through to here. If this capacitor were shorted or very leaky, then the 120 volts coming from the power line would be more or less sitting right here, and would be on the chassis, waiting for you to grab the chassis while holding on to your faucet. Might be the last thing you ever do. So so we need to make sure this is a good capacitor. We can't have a leaky capacitor here. That's bad. So that's a target. And the other one I pointed to was a big one. So if we look at the list of capacitors here, who's a big one? There's a big one there, 0.25. And that's it for the big ones. 0.2. So this has to be at C13. Must be the big one we saw on the radio. C13 is this guy. Now, is this somehow quieting the screens? So here it appears to be connected to, I find this a little bit confusing in the power supply, but I think we can call this B minus here, I think. And so this side's on B minus. Looks like this is the cathode here, so that would make some sense. B minus. And what's happening over here? I've never been able to figure this out exactly what they're doing. So you have, I'm not getting this right. So we have the positive. No, this is B minus running along here, or the minus side of the B power supply. So we have the minus here, and over on this side we have the minus. We have the minus on both sides. Is this, is this connected? I mean, look how they've drawn it here. This is all very strange how they've drawn this. I think there's a dot there, and I can't imagine they would draw the line through like this. Why would they even do that? Because this is just a spare terminal on the tube. Doesn't do anything at all. I don't get it. Why they've shown it like this. So clearly I'm not getting it. Now, so what is C13 actually doing? Big capacitor. Wow. Am I mistaken about this? I don't think so. I think it was pin 6. 1, 2, 3, 4, 5. Yeah, 6. Which is nothing in the tube. So hard to tell from the way they've drawn it here because it's just too tight. But I believe this is the cathode connection here. Well, I'm not even sure of that. Okay, wow, I'm really just kind of babbling around here. It's not clear to me what this capacitor is doing, but it's worthy of replacement, I'm sure. Let's do those two. We'll do the big guy, C13, and we'll do the killer, C7. I should apologize for babbling so long while we were looking at the schematic. I'm going to take out this capacitor. Oop. What's going on here? It's a lively one this morning. Let's see. Take out that one just because my steel trap memory needs help now and then. And we're going to cut out this one also. Yeah, I'm assuming this is the 0.25. It's probably a pretty darn good assumption. Okay, let's take these guys and give them a test. This is a 0.25. They don't look that bad, you know, as old capacitors go. Sometimes you get these capacitors coming out of the radios. The wax is completely gone on them. They're dry as a bone. Dry as an old wax capacitor. We'll do the big guy first. Just going back to the schematic, just thinking about it for a minute. My experience with schematics, I've looked at so many, is some of them, for me, communicate very, very clearly how the radio operates, and everything kind of makes sense in that. And other schematics leave me scratching my head, like the one we've been looking at. I have trouble interpreting it. Okay, watching the eye at 50 volts. And it came open. Okay, 150. Yeah, it's going to open. So, not the worst a capacitor could be. Probably not having a significant negative impact on the radio. Now, if you notice, I'm not measuring the capacitance of these capacitors. I'm just measuring their leakage. I don't bother trying to measure the capacitance. Okay, 50 volts on this guy. He's opened up halfway. 150, I doubt it'll open at all. So a little bit of a worse state, but also this guy's just going to the chassis. Now, is that leak as indicated by this device sufficient to, you know, declare this to be a dangerous situation? Jeepers, I don't know. I don't know. Would you get a bigger lift off if you had this thing unfortunately plugged in the wall in such a way the chassis was hot, and you put your hand on it like this, and then you stuck your bare foot on your damp concrete floor? Would it be worse with that slightly leaky capacitor? I don't know. I'm not going to find out. I'm not going to go and find out. Okay, so I'm going to install 2 new capacitors, and then we will test the radio and see that it's still working. Okay, I got those 2 capacitors in. Let's give this guy a test. Just after I straighten it up a little bit there. So I've put in a special capacitor here, which is designed to be in positions where it's right across the power line, where if a short circuit occurs, you could get a rather large conflagration happening in your radio. These capacitors apparently just don't catch fire, don't blow up, or something about them is unique anyway. X-type and Y-type capacitors. for this, for the power line filtering. Okay, I think we're all set. So it's this one and this one. I just put in a nice yellow, a nice orange. Hey, it's a nice looking radio now, isn't it? Volume down. Oh, smoke's way down. Okay, here we go. Dim bulbs, of course, just in case they booped up. You know, I could drop a little tidbit of wire somewhere down in the radio and not even know it. So as much as I might think there's really no need to use dim bulbs, as usual, what I think doesn't really matter much. Okay, we're waiting now. Come on. She is a slow one. Okay, so we're getting a chance now to hear the speaker itself. It could be distortion in the radio, but let's just listen for a little bit and hear what it sounds like. And I'll turn it up a fair bit too.
He was incredible on home ice, and he's the only goalie that you've won a playoff series with since I was in high school. His game has also bounced back, and as we've gone over many times with this player, he seems to thrive when he gets the net, and he seems to...
So it's reproducing a voice just fine, but that's not a good test because people's voices are very, very characteristic, and there could be things going on in the radio generating characteristics in a voice that you wouldn't recognize as being from the radio. You just think, oh, that's the guy's voice. So, but it's definitely working. It's got some volume. That was up full, by the way, to get that level of volume, so it's still not producing really what it should. Okay, where are we on the clock here? I think we still got time to do a little more. Why don't we do these next two? Let me turn this off. Stick my finger in it. We'll do this guy and this guy, and I'll try and figure out what they are. We'll take a look at them on the schematic before I replace them and talk about why they're in there as best I know. Anyway, you know, I don't know everything about these radios, of course. Okay, so the two wax capacitors we're looking at are this one, C14, and this guy, C8. Now, when I replaced this one, I stuck in a special X-type, or yeah, X-type capacitor. Probably wasted it here. I should have really put it in this position, but I'll just put another one in. So this one is obviously right across the power line. It's on the far side of the switch. So in this radio, when the switch is open, nothing is able to conduct current in the radio. Some of these radios, this capacitor will be on the other side of the switch. And as long as you plug in the radio, the capacitor is feeling 120 volts day and night. So probably not the best thing in these old radios. So and keep that in mind if you have an old tube radio, that you just don't leave it plugged in when you're not using it, just in case. And I guess that could be said about anything and everything in your house, but we obviously don't run around unplugging everything all the time. So that's this one, and then this guy up here. So he's basically right across the output of the output transformer, and his job is to quell any high frequency harmonics that have made it through this radio, through the audio circuits. These tubes are not, how can I say, you will get harmonics, or potentially have harmonics developed in these tubes because of nonlinear operation, and those harmonics are either a waste out here, you're not going to hear them because they're too high a frequency, you're just wasting power a little bit, or in fact you are going to hear them, they're going to color the sound a little bit. So in goes a capacitor here to snag the highest frequencies and do away with them, so they don't charge up the transformer here. So that guy, how big is that one? So you wouldn't want to fool around with the size on this capacitor, C14.02, because if you make it bigger, you're going to muffle the sound. If you make it smaller, you may let through more harmonics than intended. 0.02 there, and this one here, C8, is a 0.02 kind of also, 0.025. Okay, we will change those and then test them and test the radio afterwards. Okay, cut the two capacitors out, 0.025, and this was supposed to be a 0.05, I think. Can't remember now. Can't really read it. Okay, let's give them the test here. My clip lead here, the red one, is just about to break, so it can break at any time. So this first one is the 0.025 capacitor, and this is the one that was, I believe, across the output. Transformer, across the input of the output transformer. Okay, 50 volts, watch in the eye. Right open. There we go again. 150 volts, can't even open it a bit. No surprise there. So all in all these capacitors I'm testing from this radio are proving to be a little better than average in an old radio like this. And it's probably reflective of the life journey that radio's been on, how much time it's spent in somebody's garage and stuff like that. Here we go. That one opened up pretty good. How about 150? No. No. Not happening. Okay. These two, their positions, not critical if they're leaking a little bit. It wouldn't really matter, I don't think. Okay, so I'm going to put the this type here across the power line again, or for the first time, and the other capacitor in there. Okay, I will do that, and then we will test the radio once again. Okay, I think we're ready now for another test. I've got the additional capacitors installed, so there's no wax capacitors from here down. There remains one, two, anyway, two, maybe one up above that. Get you up there. Okay, we're all set here. Let me just get this. Really just making things a little bit safe for powering up the radio. Good. There we go. Here we go. Switch is on. Dim bulb's working right. Patience. A lot of patience. Let's give it the full Lammy. It's so unnerving how slow this radio is.
How long is a power play? You miss 100% of the shots.
Because you don't...
Americans don't know about hockey. So why bet on hockey with one of his sports books? Sports Interaction, your homegrown sports book.
Well, you mean Americans don't know anything about hockey? That's kind of nonsensical. I think they know lots about hockey. Okay, radio's operating. We're left with a couple more capacitors to do. Then we do a general assessment of the functioning of the radio, both the broadcast band and shortwave band. Kind of make an assessment of how well it's operating. And then after that, assuming that that is satisfactory, then it's alignment time, and we just go through, check the alignment. If it's off, we correct it, and then the radio should be performing as good as when it did when it came out of the factory. or so. Maybe even better. Is that possible? Okay, so thanks a lot for watching, and we'll see what happens tomorrow. Last couple capacitors. See ya.